Hello, good afternoon, everyone, dear authors and invited guests. Welcome to the technical session 3B. Myself, Aarthi Mohan, and I would be moderating this session. On behalf of Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of the conference is being organized in a hybrid mode, and the virtual event is being held through Zoom today and tomorrow, that is 21st and 22nd February 2024. I hope you all will enjoy this knowledgeable and interactive session through the day. There's another request to in this session, we have 6 presentations. Each presenter will be given 12 minutes for the presentation and 2 minutes for the question and answer session round. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any sort of query or update, you can write it to me in the chat box. Just before we get started, I would like you to introduce to the chair for this session, Dr. Shang Lang Pen, the professor. He's a professor and the director head of the Department of Creative Technologies of Product Design in National Taipei University of Business, Taiwan. His research interests are in designing and analyzing algorithms for bioinformatics, combinatorics, and data mining and networks, areas in which he has published over 100 papers. Sir, it's an immense pleasure to have you on board with us. Welcome you, sir. We have another session chair, Dr. Astha Parekh. She's an assistant professor, selection grade in IIS, deemed to be a university in Jaipur and in India. And she is she is an assistant professor in the Department of Computer Science at IIS Jaipur since March 2010. Her research interests lie in the area of programming languages, data mining, cloud computing, and sentiment analysis. Ma'am, it's a pleasure to have you on board with us. I would request the session chairs, if you require any addition, could you please introduce yourself?
No, I'm fine. Thank you.
Thank you, sir.
Thank you. Thank you.
Okay. Thank you, ma'am. So moving on to the first presentation, I would like to invite Pet Klan to present his paper on communicating universe. Dear presenter, could you please start with your presentation? Sorry, you are on mute.
Microphone.
Okay.
Oh, yeah.
Okay.
Yes, perfect. Good.
Okay. And now, please, how to start presentation? It means I have video, I have presentation, and I don't know how to start it. I don't see anything. Yes, I have as PDF file, or I can start video. Yes, I don't know if you see it. Yes, I can start it.
So you have an option there at the bottom, share screen. So you can share.
Option, where is option? Yeah. Yes, I have mute. It is okay. Video.
Start video, participant chat, share screen option is there, sir. Is it visible?
Yes, security, share screen.
Yeah, so you can click on that and share the presentation or the PDF.
Share screen, yes?
Yes, sir.
Okay, I try, yes. Okay. And now where to start presentation? Yes, share screen, yes. So I try to start, yes. I try to start video and we shall see. Yeah. Yes, it means documents. And you will see, I recorded video in virtual reality. Yes, here I have. So let's start. Do you see it?
No, no.
From somewhere in universe. You see, I am in digital world with some elements, some important elements of our life. It means here is a three-dimensional model of grain of copy. Here is so-called watch controller, was first automatic controller. Here is so-called client model with one surface. And
So could you please share your presentation to us in the chat box?
Table with square root
Yes, there is some
of
background noise.
yes, it's 1007.
Okay. So could you please share your presentation in the chat box? I can share it on your behalf.
My presentation today is concerned on communicating universe. My name is Peter Kran. Hello. Hello. You see, my avatar is the same as physical. And I would like to present the communicating universe. It means I would like to present a procedure or concept how to connect micro and macro worlds in physics. It means how to make a unity picture of physics. First, begin from information. Yes, this unity picture, it is based, or I propose to be based on information. It means on communication. Yes, in communication, we transfer information. And basic channel concept, how to measure information.
So you can do one thing, you can share the presentation in the chat box so we can proceed further. So can you hear me?
Yes. Excuse me?
So you can share your presentation in the chat box.
Presentation, which kind of presentation? I don't see. Information. On the other side, if we have probability, small probability close to zero.
So whatever the presentation you are sharing, you please share on the chat box.
So it gives information by here is basic table. Yes, please, we forget on entropies, we forget logarithms, because in fact entropies are in fact average informations, and logarithm is only different measure. So we start or we take basic ratio 1/3. So if you take this information, and if you take it for terms, in fact, in universe we have periodic events, many periodic events. Yes, consider periods, consider two periodic events, consider periods T1 and T2. Yes, for example, we have 1 day and 1 year. Yes, it means first period of day is 1 day, and period of year is 365 days. The Venus cycle, yes, here against the year, yes, Venus period of Venus is 584 days, and 1 year it has 365. And we would like to calculate information based on these events, periodic events. And it is possible to derive that information 1 over E is equal 1 plus and the ratio of 2 periods. And the ratio of 2 periods, it means if you take it in general, yes, every ratio of times brings information. And if you rewrite this equation, yes, you obtain left side and right side, which is equation. Yes, it means here we have information minus 1 multiplied by time is equal. But we ask for, or we look for the same units. Right? So it means I'm asking, yes, if we measure time in bit seconds rather than seconds, and consider general ratio. Yes, I would like to start from odds. Yes, in practice, we use odds. Yes, it means that your team wins, and all chance is, for example, 3-to-1 ratio. There are odds. We use that. But we can ask which probability it is. It means that we have got A to B as ratio, where A, B are positive numbers, and we can ask for probability or chance to win or probability of success. Yes, and it is possible to calculate. Yes, as probability is as ratio A over A plus B proportions. And I can calculate information by the same way. Okay, I can calculate information as 1 over B, it is 1 plus B over A. So here I have equation, I have concept, general concept. How to calculate information. An example, if I have got 2 to 1, yes, I obtain information 1.5. Yes, it could become more complicated. I can have it needs chance to win B to 1. So I obtain information 4.1415. It's 1 plus B, 1 plus 5. And it gives me general concept how to measure information, and now physics is full of ratios, macro world and micro world. So information can, if physics, one picture, one figure. Consider, for example, average speed as it stands over time. So I can easily calculate information based on ratio as 1 plus E over S. So if I have average acceleration, yes, again, it is possible to calculate information. I have law of gravitation. Yes, again, it is ratio. Yes, I can calculate information. If I use calculus, yes, if I have differential ratio, again, I can calculate, again, I can calculate information. Yes, I did over ds. This is a positive ratio. It is from macro world, and now from micro world. Yes, here I have a radial probability of hydrogen atom. Yes, this one. And I gave immediately, yes, calculate its kind of quantum. Yes, it means that I can immediately calculate information as 1 plus 1 over PR and this radius. So you see, I have information. I have one picture, yes, on physics from macro world and micro world. So now, yes, I can, based on this, yes, I can construct one picture of the world. So I can compare, yes, one picture, yes, to one figure. I can place, yes, for example, gravitation versus hydrogen atom. Yes, hydrogen is blue, and gravitation law is red one. Yes, they are proportional. Or again, yes, in this macro world and micro world. And here again, yes, I can in one picture, yes, I can have, yes, Kepler law, which is macro world, and hydrogen atom. Again, yes, red one means Kepler, and blue one means hydrogen. You see that they are very similar in type. Yes, proportionally.
So,
Sure.
so last 2 minutes, could you please conclude your research?
So to conclude, I have some concluding questions. Yes, it means the role of space-time, because if you study, if you observe ratios in physics, so you see that in denominators, you often meet time and space. It means it is a reason, it is this reason why space-time plays so big role in physics. Because space-time, because space, because distance and distances and time, yes, increases information. Second, yes, there is possible degree of uncertainty if you take special relativity. Yes, you obtain that our universe, our universe, it means our Earth. Yes, have a very special concept. It means that we have maximum uncertainty. Maximum uncertainty is 50-50. It means it is probability 0.5, 1/2. Yes, but it is only for speed. It is special relativity for speed is 0. Again, yes, sir, question, yes, is time more important than space? Because time is more oftenly to see, to observe in ratios. So I can ask if time is increasing for So it is, I study it on this figure. Yes, here you have hydrogen atom of quantum, and here you have sun. Yes, it means this situation, this concept in which I have one picture. I have quantum concept and micro world concept and macro world concept. So it means I presented that we can use communication as an element between macro world and micro world, just to obtain a unity, bigger unity picture of micro world and macro world. So I am asking this from my paper, from my title of paper. So we live in communicating universe. So thank you for your attention.
Thank you, sir. Thank you for your presentation. Ma'am, you have any questions, sir? Any
No,
questions?
ma'am. No, ma'am. Thank you. Thank you.
Okay. Thank you, sir. Thank you for your presentation.
Thank you.
Moving on to the next presentation, I would like to invite Dakshayani MN to present her paper on design of deep learning based intelligent blind direct sequence code division multiple DSCDMA access. Dear presenter, could you please proceed with your presentation?
Yeah, yes, thank you, ma'am. I am Dakshayani. Good evening, all. I'm going to share my presentation PPT. Is it visible, ma'am? My presentation PPT slides?
Yes, ma'am, it's
Am I
visible.
audible?
Yeah.
Thank you. Shall I start, ma'am?
Yeah, sure. Please proceed.
Yeah, thank you. Good evening, all. My name is Dakshayani. I'm a research scholar from School of Electronics and Communication Engineering, Reva University, from Bangalore, Karnataka, from India. Today's presentation, my topic is design of deep learning based intelligent blind direct sequence code division multiple access receiver. This is the content of my presentation. Direct sequence code division multiple access is a multiple access method in which the multiple users simultaneously can use the same frequency band. In our proposed work, we have designed an intelligent blind DSCDMA receiver by using the latest deep learning technique. Specifically, we have used convolutional neural network in regression mode. Our designed intelligent receiver successfully can identify the transmitted signal, though there is a substantial presence in the noise distortions. With a zero error, it can identify the transmitted data. Our proposed designed receiver, the experimental findings demonstrates that our proposed intelligent receiver performs better when compared with the model based one. In a real world communication, designing an optimum receiver is the most challenging task because when we transmit this signal through a communication channel, that signal suffers from the multiple multipath propagation, then multipath fading, frequency shift, attenuation, and many more. So these impairments need to be addressed. To address this, the solution is to design an optimum receiver with the latest technology using a deep learning technique. So with respect to my research work, we have referred some of the work related to our research work. We have done the survey on this related topic. A few of the survey paper I have listed here. The first paper, which in this paper they have done the designing of the DSCDMA receiver using a blind signal detection method, and in this the limitation is more processing time is needed. The improvement can be done as processing time can be reduced. And in the second paper, they have designed a sliding bidirectional recurrent neural network detector by using the recurrent neural network method they have used. In this paper, it has a higher bit error rate. The improvement can be done as the bit error rate can be reduced. In the third paper, they have designed intelligent receiver using the method feed forward neural network, that is deep learning method they have used. In this, the additional pre-processing and relatively longer training period, the performance improvement can be done as pre-processing and training period can be minimized. In this fourth reference paper, they have designed DSCDMA transmitter and receiver using DSCDMA blind inverse spreading anti-collision method they have used. In this, more computational complexity and the improvement can be done, computation complexity can be minimized. In this reference, MMSC receiver they have designed using the technique multiple access interference in multi-carrier code division multiplexing. In this, unpredictable changes in amplitude and phase within the received signal. That is the limitations. The performance can be improved when the dimension of features are can be lowered. So in this during this survey, we have found the research gap that existing transmitter receiver system design results in a relatively a low data rate with a more distortion and higher bit error rate, maximum crosstalk, close signal to noise ratio with more latency. We have addressed with a bit error rate in our intelligent receiver. The figure demonstrate the DSCDMA communication model, where which consists of the transmitter, channel, and the receiver, that is CNN IR, convolutional neural network intelligent receiver, three sections which consist of. In the DSCDMA transmitter, we have the input signal D1, D2 up to Dn. That is the binary input data. We have used n number of users. N is the number of users we can use, and another input is orthogonal signatures, that is represented by S1, Si, and Sn. Then in the figure, A1, AI, and AN, which represents a gain factor of the channel. So these three, it is given to the summer, and C is the composite signal. The composite signal is the product of orthogonal signature, input signal, and the gain factor. That composite signal is given as input to the channel, communication channel. When the signal is transmitted through the channel, it will be distorted by the noise. So the output of the channel is the X, represented by a X. X is the summation of composite signal and the noise. That signal X is given as an input to the convolutional neural network intelligent receiver. This CNN, we have designed this. Later I'm going to explain the method, like how we have designed this. So the output of CNN is represented by a Y. Y has to detect the signal, transmitted signal D, by removing the distortion and noise. So here are the equations, that is input signal is in the previous figure we have represented D. So D is a column vector with the elements D1, D2 up to Dn, and orthogonal property for the orthogonal signature is represented by this, that is Si of transpose convert the S of J is equal to 1 if I is equal to J, and 0 if I not equal to J. That is the orthogonal property. And the composite signal we are representing, that is from the diagram we have seen, it is a summation and a product of orthogonal signature, then the input D of I, and the gain factor A of I. And output of the transmitter is the output of the channel is X. X is a summation of composite signal and the noise. So our aim is to identify X is the input to the receiver, and from the receiver we have to identify the transmitted signal by removing the noise. So our proposed method is convolutional neural network intelligent receiver. We have used convolutional neural network with a regression mode we have used. The main objective of this receiver is the detected the output should be same as the transmitted signal, that is D. Suppose if it is not same, then this CNN receiver is retrained so that the output should be same as the transmitted signal. If not, if there is some error, again we are going to retrain the convolutional neural network. We are going to retrain so that until the error is zero, that is D minus Y, where Y represents the output and D represents the transmitted signal, D minus Y, E should be zero. If E is zero, successfully we have trained our intelligent receiver, and it can clearly identify the transmitted signal without any noise. For our design, we have used these hyperparameters. For our design, we have used, that is CDMA data length 8 we have used, and we have also used X train, Y train, X validate, X train, X test, and these are the hyper parameters we have used for our design. The number of epochs we have used is 200, and the minimum batch size we have used 45, and initial running rate is 0.005. So these are the hyper parameters we have used in our design. How does the CNN detector works? It has basically three phases: CNN training phase, CNN test phase, and CNN application phase. So here in the diagram, like we have represented two different phases, that is CNN training phase and test phase. During the training phase, the input to the CNN network is X train and Y train, where X train is input X and Y train, X train is the input and Y train is the output. Input and output we are giving as input to the CNN network, as a input we are giving. So we are going to, as in the table represented hyperparameters we have used, and we are going to train the CNN. We have used different possible of the input to perfectly train the CNN network. So once CNN network is trained, then the next phase is CNN test phase. For the CNN test phase, we are going to give input as a X test, where X test is the input, and output of this training phase, we are going to give one more input for CNN testing phase. So in the testing phase, Y predict will be there. Then X test and Y predict is the input to the testing phase, and which gives the Y class as the output. Y class should be same as the Y predict. So once this Y class and Y test, if both matches, then error is a zero. So like this, if error is not zero, we are going to retrain by changing the parameters. We are going to retrain the CNN network until error becomes zero. So once error becomes zero, it says that CNN is perfectly trained. Receiver is ready for the deployment phase, that is application phase. Our trained CNN network is ready for the application phase. We can for the deployment phase, where it can receive the data and identify the transmitted information with a zero error. So here, like flowchart
Ma'am,
is
sorry to,
here. Yes,
ma'am, sorry
yes.
to
Can you?
you have, yeah, you have left with 2 more minutes. So could you please conclude your research?
Sure. So this is the algorithm. We have used for the to train the CNN network, and we have conducted the experiment to measure the performance of our receiver in terms of percentage error. So we have considered 200 epochs with different SNR from 7 dB to 1 dB. We have reduced in steps of 1 dB. So we can from the experimental results we can see that as number of epochs increases, our percentage percentage error reaches to 0. That is at 7 dB. 7 dB and greater than 7 dB, the percentage error is 0 at 200 epochs. And also when SNR decreases, the percentage error increases. So we have achieved 7 dB SNR, greater than 7 dB SNR, we reached percentage error is 0. We can detect, we have trained CNN network, a CNN network with a 0% error, so that the output will be same as the transmitted input. So I would like to conclude that we have designed a novel blind intelligent DSCDMA receiver. By using the deep learning technique, specifically we have used convolutional neural network in a regression mode. So the designed receiver successfully can identify the transmitted data with a 0 error. Our experimental result shows that at 7 dB or greater than 7 dB, 0% of error. With 0% of error, we can identify the transmitted data. Thank you so much. And this is the reference what I have referred. Thank you.
Nice presentation, ma'am. There are few
Thank
questions.
you.
Ma'am,
Yes,
are there
yes.
any ethical considerations related to the deployment of intelligent blind DSCDMA receivers, especially when we talk in terms of privacy and data security?
Yes, ma'am. It is highly secure. Data is highly secure since we are using a deep learning technique. The data is it is highly secured, ma'am.
Okay. Secondly, how can the model be designed to avoid the biases and ensure the fair treatment across different users?
Uh, uh, we are using blind. That's why like it is called blind, ma'am. Blind in the sense like additional information we are not using. Suppose if n number of users are using this, some users are unusers. So that unusers will be eliminated from this and only users will be considered in this design, ma'am, circuit design.
Okay, okay. Thank you.
Thank you, ma'am. Thank you.
Thank you, ma'am, for your presentation. So you have any
Thank
questions?
you. Myself?
No. So
Okay.
okay. So yes. Okay. Thank you so much for your presentation. Moving on to our next presentation, I would like to
Thank you.
invite, yeah, Mohammad Nadim Kaiser to present his paper on English to Bangla language translation, a comparative study of GPT-3 and attention-based encoder-decoder. Dear presenter, could you please proceed with your presentation?
Yes, thank you. Is my slide visible?
Yes, it's visible. You may please proceed.
Thank you. Thank you, everyone. I'm MD Nadim Kaiser, and this is my presentation titled English to Bangla Language Translation, a comparative study of GPT-3 and attention-based decoder. My paper ID is 219, and I'm right now presenting this paper. Here is the content, background, objective, data example, methodology, experiment setup, result and discussion, error analysis, conclusion, and future work. About this content, I will discuss in this presentation. So background still, people are struggling English as an international language, especially Bengali speaking root people and countryside of people also struggling with same issues. As a result, they are unsuccessful to finding information from first repository of internet because of information is in English. To remove it, the language barrier or come artificial intelligence based process machine translation has been adopted. There are different kind of method for machine translations. One of the traditional method right now, sequence to sequence model, and another right now trending issue, large language model, chat GPT, GPT-4, GPT-3 right now. Another method can be large LLM-based GPT-3 model. So in this study, I have comparative study between this sequence-to-sequence model and LLM-based GPT-3 model, how it's perform low resource language for machine translation. So objective of this study to identify performance of LLM-based GPT-3 model for low resource language such as Bengali, and to comparative analysis between GPT-3 and sequence-to-sequence model. Another one is to investigate current LLM performance in low resource language to build a translation service method that help for root people to understand English information after the translation into Bengali language. Here is my data example, and for sequence to sequence model, here is the actual and expected result, expected and actual and expected data. And for GPT, we need to define some JSON data format where we need to prompt and completion. Here we design our GPT data for training and testing. So in my methodological architecture, here is my methodological architecture for this study. First, we have collect the data set and save it to CSV and load it to data frame. After that, we conduct some pre-processing such as noise identification, noise remove tokenization. After that, we split it some training and testing data. After that, we model selection, which model we train. Then we use here two models, sequence to sequence model and GPT-3. And after that, we generate the output, generated output we analyze. So for fine-tuning the GPT-3, after the data formatting, we design the prompt and completion. Then after that prompt in context learning. After that, it's go to LLM service through large language model or GPT-3 API service. Then we did it the fine tuning. After the fine tuning, we as a user we use it through API based on prompt or based on the prompt. And here is the sequence-to-sequence model design. The sequence-to-sequence model, we use multiple level of encoder through recurrent neural network, and every recurrent network have some hidden state, and every hidden state combinedly we use here some context vector, and for this context vector we pass it through the decoder, and decoder have some multiple RNN cell. Every cell output has design output is as a translated language. Here is my experiment setup. The total size of data 4,387, and training data size is 90% of this data, and testing data size is 10%. We use two kind of model. One is GPT-3 and another one is sequence to sequence model. And we use for GPT 80 epoch, and for sequence to sequence model we use 20 epoch. Batch size is 0.2 for GPT-3, and for sequence to sequence model we use 32. And another we use learning rate. For GPT-3 we use for 0.05, and for sequence to sequence model we use 0.1 learning rate. Here is, and this is my experiment setup here. And in our result discussion is divided into some subsections, such as first one is accuracy-based performance analysis for translation. Second one is embedding-based analysis. Third one is blue score analysis. Fourth one is human-based manual analysis. So first one is model accuracy analysis. We found for sequence to sequence model 96% for training accuracy, and for testing accuracy we got 0.81 accuracy, and for training loss for sequence to sequence 0.095, and testing loss 1.47. For GPT-3, we got 19% training accuracy, and testing accuracy 94% almost. And for GPT-3, we got loss 0.06, and testing loss we 0.74. Here's the embedding based analysis. We did some embedding based analysis with some embedding methods such as what2vec, BART, and GPT-3 embedding vector. We use cosine similarity between actual sentence and expected sentence. We found here cosine similarity for what2vec 0.70, and for BART we found cosine similarity 0.72, and GPT-3 we found the cosine similarity 0.77, and we also find out some Pearson correlation, Spearman's correlation. Every model we found that GPT-3 is better than some others embedding, such as if we talk about the Pearson correlation, we got 0.76 correlated the actual sentence and expected sentence, and Pearson correlation we found 0.75. And here's the blue score analysis. We use here also sequence to sequence model and GPT-3 model. We found for blue score 0.74 for sequence to sequence model, and for GPT-3 we got 0.85. And here's the human-based manual analysis. We choose the 200 random sample for human evaluation, and the participants try to evaluate semantic meaning, actual and meaning of actual and expected sentence or translated sentence. We have found a 19% accurate sentence, which is evaluated by participants for GPT-3, and finally we found 78% accurate sentence, which is evaluated by participant for sequence to sequence model. Here we try to find out some error analysis, such as grammatical error, semantic error, syntactic error, and lexical error, fluency error, omission error, some additional error, ambiguity error. And here also we find out some human-based error analysis. We found the almost sequence to sequence model is not so good for the translation. Is right now GPT-3 is better than others model, such as for GPT-3 we found only grammatical error, 2 semantic or meaning error, only 5 syntactic error, only 2, and ambiguity we only found 3. But sequence to sequence model we found lots of error rather than GPT-3. Such as only grammatical error we found 8 out of 20 out of 200, and a semantic error we found 10, syntactic, lexical, fluency, and others found we also 4. And conclusion, we proposed a study conducted by GPT-3 and sequence-to-sequence model for machine translation. We have shown comparison between GPT-3 and sequence-to-sequence model, and the study has shown a separate process in the pipeline for each module. And finally, we have found the comparative better performance and for this proposed GPT-3 model. And for future work, for improve the context vector for sequence-to-sequence model, we'll try to improve the context vector for sequence-to-sequence model. And secondly, we try to increase our data set for training. And another one is we will try to handle the idiomatic expression, because large language model, we found that still large language model struggling for translation when it's idiomatic expressions found in sentence. And finally, we try to develop a web service for English to Bangla language machine translation. And thank you.
Thank you so much. Just one question.
Yeah, please.
Can any specific model or approach provide a better experience or performance in certain domains?
Yes.
Okay. And how does the efficiency of these models vary in different fields of application?
What do you mean by different kind of application? Could you tell me?
Any other applications we can use this?
Yes, we can use this any application. And how we adapt for any application, and we can use the fine-tuning model for any application. We can use the API service for this fine-tuning model.
Okay, thank you.
Thank you.
Thank you so much for your presentation.
Thank you.
Moving on to the next presentation, I would like to invite Santiago Rios to present his paper on Goose Flow Meter, a flow extractor for the analysis of Goose messages. Dear presenter, could you please proceed with your presentation?
Yeah, thank you. Okay, can you confirm that you see my slides?
Yes, we can see your slides. Could you please proceed?
Okay, thank you. Good afternoon. My name is Santiago Rios Viral, and I will be presenting the paper Goose Flow Meter, flow extractor for the analysis of Goose messages. In the outline for this presentation, I want to start by giving a brief introduction about power substations. I want to introduce the Goose messaging protocol. I present problem statement and the proposed solution, that is the Goose Flow Meter extractor, followed by the experimental setup and the results and conclusion from this work. But first, in this introduction, I want to highlight the importance of power substations and the electrical sector in order to carry out daily activities. Other sectors such as petroleum, water supply systems, transportations, communication, and finances depend on the correct operation of power substations. Now, a power substation is a vital critical infrastructure that enables the efficient and reliable transmission and distribution of electricity. So by targeting a power substation communication system, it could result in power failures that might disrupt essential human activities. For example, in the government, finances, transportation, and even schools. In that matter, the IEC 61850 standard defines guidelines for security measures and communications. For instance, the standards define the Goose messages as a protocol for transmission of event-driven information. Additionally, it is paramount to protect cybersecurity, to apply cybersecurity measures to power substations. In that matter, it is fundamental the analysis of goose traffic and the implementation of new tools. In this context, the proposed solution is goose flow meter that allows analyzing the behavior of goose messages from the flow perspective. Now, what is goose? The standard defines the goose messaging protocol as an event-driven mechanism that enables information exchange among intelligent electronic devices inside power substations. And furthermore, goose messages allow the transmission of real-time events related to status changes in a power system of a substation. Here I present an example. In the animation, I present a general diagram of a power substation where a goose message can be sent from a publisher IED to a subscriber IED. For example, if we have a control IED that is sending a goose message to an input-output IED, the message could carry information about changes required by power machines in order to generate the required electricity. Then, from my work aiming at providing security mechanisms to power substations, we have the following question. How can we further advance the analysis of goose messages in power substations? Here, it could be useful to have a new representation for this kind of messages. For example, network flows can provide a data representation that offers valuable insights into the behavior of network traffic. Additionally, by defining a flow identifier, it is possible to aggregate network packets based on a shared key. In this work, we have introduced a definition for goose flows that is based on the source and destination MAC addresses, the application ID, the goose control block reference, and the status number. In this way, through the proposed extractor, it is possible to slide network traffic inside a power substation according to their tags. For example, we can define flows for protection or for control activities. Then, in order to analyze the behavior of goose messages, we have proposed a solution that is called the goose flow meter extractor. It will allow us to aggregate goose messages into flows. In this slide, I present a general diagram of the tool. If we start here in A, the input data for the extractor can be obtained from listening to a network interface or by reading a picket file. Then here in B, in the main module, the sniffer captures the goose messages and we start a flow session in order to aggregate those messages. In C, the goose parcel will extract the data of the packet, and also we will extract the payload that is corresponding to the goose PDU. This information is sent to D, to the PDU data collector, and then we have to ask the following question. Is there an active flow? If the answer is no, we go to the E, to the flow key definition, and based on the proposed key, we can start a new flow. In both cases, the next step is F, where we will extract the features, and then in G, we will collect those statistics in a flow structure. And this process is done for each packet that is captured by the extractor. Then when we finish a flow, we go to the closed flow session and we store the flow information that could be sent to H, to an inference model. Here we have a classifier with the help of a machine learning model, and this will send an alert to the network administrator in the case of an occurrence of a cyber attack to the power substation. And finally, here in I, we have the output of the extractor that is saved into a CSV file. Now, to evaluate the correct functioning of the extractor, we designed an experimental setup where the first host is acting as the attacker by impersonating the publisher IED by sending false data injection attacks to the subscriber IED. Then we have a second host where we deploy the goose flow meter extractor to generate the goose flows. From this experiment, we captured more than 13,000 goose messages, and we extracted more than 3,400 goose flows, where each flow has 45 features, and the traffic is 87.4 benign flows and 12.6 FDI flows. And the generated dataset was used to train and test the detection on a FDI attack. Then, in order to prove the usefulness of the extractor, we implemented a classification algorithms, and we focused on 4 metrics: the general accuracy, the false positive rate, and the false negative rate will give us information about misclassified flows, and the true positive rate will tell us about the correct detection of FDI attacks. From these results, we can highlight that we obtained an accuracy superior to 93.8%. And furthermore, we obtained 84.0% correct classification of false data injection attacks. Additionally, I want to highlight 2 models, the decision tree and random forest, with general accuracy superior to 99% and the correct classification of false data injection attacks superior to 95%. Now, from this work, here in the paper, we introduce goose flow meter. It's a network extractor that will allow to extract goose flow-based information. By leveraging the introduction of a goose key, it was possible to extract goose flows in order to extend the analysis of communications in power substations. Additionally, the extractor can be used to generate goose flow datasets in order to create automated models. In our work, it was proven to be useful in the application of security mechanisms to detect false data injection attacks. And finally, through goose flows, it is possible to identify cyber attack patterns that are not easily identified at a packet level perspective. Hence, goose flow meter is a valuable tool and can be a useful component of an intrusion detection system. Thank you so much for your attention. Now, any questions?
Yes, I have one question. How stable is the goose flow meter for large scale networks, and does its performance remains consistent as the network size increases?
Sorry, can you repeat the question, please? I have a problem here.
I'm asking, hello, can you hear me? How
Yeah.
stable is the goose flow meter for large scale networks, and does its performance remain consistent as the network size increases?
Yeah, so the extractor is stable due to their ability to focus on a network interface. Therefore, there is no problem if we can deploy the extractor in different part of the network, and there is no problem if the network keeps increasing in size.
Okay. Last question is, are there specific use cases or scenarios where the goose flow meter excels, and are there limitations in this applicability?
Yes. For example, if we apply it to security mechanisms, we can obtain new features that are not easily identified if we look just to a packet. For example, a really important feature in order to detect an attack is the inter-arrival time, and we introduce this with the extractor.
Okay, thank you.
Thank you so much.
Thank you so much for your presentation. Moving to our next presentation, I would like to invite Antonius to present his paper on how blockchain and the metaverse can transform the e-commerce domain. Dear presenter, could you please proceed with your presentation?
Hello, everyone.
Hi. Yeah, yes, you are audible.
Yep, okay. Thank you, everyone. Hello. My name is Adonis Liadzis from the University of Macedonia in Greece. And today I will present you on how the blockchain and the metaverse can transform the e-commerce domain. What is the metaverse? The metaverse is an extension of the internet in which users can either interact with each other or with digital objects in an interactive environment consisting of virtual worlds, avatars, and immersive technologies. The metaverse is more than just a virtual reality environment. While most virtual reality experiences are limited to specific location, the metaverse is fully interactive digital universe, and users can jump from one virtual world to another, engage in real time with users, and even develop their own virtual environments. On the other hand, the blockchain is essentially a distributed shared ledger of transactions that record all the transactions between users, and the transaction is validated by the network of nodes, open to anyone to see it. The introduction of Bitcoin marked the development of decentralization in computer. However, the narrow scope of Bitcoin make it unsuitable for general purpose applications. And this need for platform based on universal application was filled in 2013 with the introduction of Ethereum, which brought the smart contract technology, which is essentially programs stored on a blockchain, run when predetermined conditions are met, and automate the execution of an agreement. So, the virtual commerce is a business activity in a fully capable virtual environment.
Please come
It
to
is
the
one-
objectives. Please come to the objective.
Sorry?
Come to the objective slides.
Can you see my slides?
Yes, proceed.
Okay. From a technical point of view, virtual commerce involves e-commerce infrastructures, digital product catalogs, and electronic payment systems, and use immersive technologies that can create new frameworks for conducting businesses, a domain that can benefit from the integration of the above technologies of blockchain and metaverse, offering eventually more value to its customers. So, why we should integrate the technology of blockchains and the metaverse in the e-commerce? With its major features, blockchain technology can add up value to the e-commerce by guaranteeing transaction immutability, the data integrity, the security for all participants, and can eliminate the need for third-party intermediaries and can increase the security and automate the transactions. Furthermore, by facilitating the direct transaction between shops and customers, the blockchain can lower product prices and can improve traceability, letting buyers confirm the legitimacy and provenance of products. While the metaverse has the potential to create a new great economy based on virtual products and services. The businesses can build and sell digital things, such as virtual real estate, clothing, and accessories. The user, on the other hand, will be able to develop, live, rent, buy, and sell real estate consisting of buildings. The properties will be available to users and can be sold through auctions with digital currency, and can also be used to host virtual events such as conferences and concerts. The metaverse is already being used for entertainment with virtual worlds such as Second Life and VR Chat, providing a variety of experience for the users. And the recent technological breakthroughs in virtual reality, such as the virtual of the Apple Provision and the Meta Oculus, have enabled this type of e-commerce. So our case study, we will, for the purpose of combining the above technologies in a way of utilizing the metaverse and the blockchain inside the domain of e-commerce, a simple virtual world in metaverse has been created. The blockchain technology allows us the creation and management of unique assets that are used to represent virtual properties or other objects inside the metaverse environment in the form of non-fungible tokens that can possess unique characteristics. Furthermore, the ability to track the ownership of the NFTs and access them through the blockchain technology can be used to develop new business models such as renting or leasing this NFT, eventually the virtual real estate or structures. The resources and tools that we have been used are the Web3 documentation that provided us with the knowledge of decentralized web technologies and how we can integrate them inside the application, the Solidity programming language that it was helpful for create the smart contract that runs inside the blockchain technology, blockchain the Ethereum blockchain, and can regulate the ownership, the asset management, and the transaction capabilities in this environment. And last, the 3GS library that provided us a visual 3D environment in which users of the application inside the metaverse can explore, interact, and engage with the virtual world. So, how we did implement this? A 3D scene was created by using the 3GS library. The object was constructed by having a background. Also, we built a scene inside with an ambient and directional light. Then, the metaverse object that we built, a cube, a cone, and a cylinder, was created. Each object is unique and is placed around the environment, providing the users with a sense of exploration and participating in this metaverse world, as the object represent buildings or shops. The cube, cylinder, and cone object that we created rotate, creating an animating effect. This is the presentation from the browser that you can insert the values that the smart contract custom structure code building is defined, and this smart contract encode the attributes of the virtual building, such the name, its dimension, and location. Organized representation, this serves as the foundation for each individual NFT inside our metaverse. Users can create NFT tokens, which represent metaverse structures. So, users must enter information about the construct and pay the appropriate cost in the form of gas in the Ethereum network. The function which is being used inside the smart contract determines if the maximum supply of the NFT have been reached and if the sender has transferred enough Ether for the transaction to begin. If all conditions are met, a new NFT is created and the information about it is stored inside the blockchain network. An animation loop, on the other hand, function, is created that handles the rotation of the 3D object and the movement of the camera based on user input. And the movement module handles the camera movement by listening to the input of the user through event listeners and notifying the camera position accordingly. The code extracts construction data from the blockchain and convert it into visual representation inside our environment. And the buildings are designed as 3D objects with custom geometry, and they are placed according to the data that the user have been applied. So we created these three objects. And if you put any input values inside the browser application, such as the NFT name, its width, height, the depth, the position of everybody, this activates the smart contract function, setting the Ether inside the network, and when the network validates all the transactions, a new object is formed. Conclusion, by integrating the blockchain technology within a metaverse environment, it is possible to create a marketplace where a user can advertise, buy, and sell virtual structures and objects. We can manage the ownership and can ensure the secure and transparent transaction, allowing users to participate in the exchange of their assets. But while we can adopt blockchain and smart contract technology in the metaverse for the e-commerce, it is critical to recognize some problems and constraints, such as scalability concerns, regulatory complexity, and the requirement and the confidence that we should accept all these significant roadblocks. But integrating this technology with the current systems may be difficult and might be expensive, and there are worries about environmental sustainability and data privacy. And smart contract vulnerabilities are still present, and interoperability issues must also be addressed. But recognizing and addressing these issues is critical for the effective implementation of blockchain and smart contract technologies in the dynamic and changing metaverse of the e-commerce ecosystem. And thank you all for your attention.
Thank you so much. One question.
Yep.
What regularity or challenges and considerations emerge with the integration of blockchain and meta reverse in e-commerce, and how can they be addressed?
The regulators is probably because the central institutions need to control the flow of money. And as you have seen in Europe, in Europe, they try to create their own digital coin that can be used all around Europe, so that it might be decentralized, but also centralized in the form of how can we secure that this coin, the euro coin, how they call it, we can how we can regulate and not let ultimately two users exchange value without us. So they try to put a small regulatory and become the intermediaries where there should not be any intermediaries.
Okay. Second question: how do user perspective and adopt e-commerce platform incorporating blockchain and meta reverse, and what factors influence their acceptance?
Yep. Because it is not a new technology, but also the users still trust the centralized solutions. And one of the problems is with their wallet, the blockchain wallet, that if you want to use a wallet, so you can participate into an exchange of value or objects, you have to create a blockchain wallet. You have to write it down at 12 phrases with a particular order. And sometimes they need that there is so much work anyone to participate. But whenever they see the value that you can transfer something from one to another without any intermediaries inside, and lately there have been some solutions that the creation of the wallet should be simpler, so that the majority of people should be exchange value inside the blockchain network. But I believe it's a time should need some more time, so that it should the blockchain technology and the technology that can back up for the metaverse and the e-commerce to be a daily life for any user.
Thank you so much.
Thank you.
Okay,
Thank you
if
so much.
may I ask, is it possible?
Yes.
Sorry.
Yes.
Sorry.
Okay.
Yes.
Please. I work in metaverse every day. You use, I think, very extremely simple metaverse. I am
Yes.
not sure if it is possible to call it metaverse, but I am asking why you not used some professional metaverse from Steam, for example,
Like Unity.
Resonite or Neos or another
Yes.
VR chat. Yeah.
We tried to create a simple form that we could put it inside the browser for anyone to have a skeleton inside the browser, and the little part of it will be the part of the creation through the 3GS JavaScript, I mean, part that could integrate with the smart contracts of the blockchain technology, so that we have an entirely eShop, and 1% of it will be according to the 3GS and the blockchain technology inside the browser. It's it's a simple form, but can be expanded so much more, and with all the tools that you have been tell everyone.
Yes, thank you. I understand, but it is possible to integrate NFT, and it is possible to integrate blockchain to metaverses which are on Steam. Yes, via visual programming, for example, it is very easy to integrate. I am not. I don't understand why you used web browsers.
Yep, I understand, but we tried to use the simple form that we could
For demonstration. Okay.
for the demonstration, and for any user that have e-commerce site in the traditional form, that could be used the simple form, and 1% of this, his e-commerce should be something that could rotate. But no, look, this rotating thing, you can sell it to anyone else and can transfer this value to anyone else. It's the simplest form. Yes.
Okay, thank you very much. Thank you.
Thank you. Thank you.
Thank you so much for your presentation. Now, I would like to invite Tribus Omar to present his paper on innovative solar battery system integration for eco-friendly electric vehicle charging stations. Dear presenter, could you please proceed with your presentation?
Do you see my screen?
Yes, it's visible.
Okay, perfect. So, good afternoon, distinguished guests. My name is Omar. It is my privilege to present a significant components of my doctoral research project titled Innovative Solar Battery System Integration for Eco-Friendly EV Charging Station. So, over the past several months, I have dedicated my efforts to investigate this topic, and today I'm excited to share my findings with you. So our presentation will start with a comprehensive background section, providing detailed insights and data to justify our choice of research topic. Following this, we will proceed to the introduction, providing an overview of our research. We will delve next into the methodology in implementation, highlighting the key components used in our study. The presentation will then transition to the results section, where we will discuss the outcomes of our simulations. Finally, we will conclude by summarizing our findings. So fossil fuel, as we know, has long been linked with economic growth since the Industrial Revolution, consistently representing roughly 80% of the global energy mix. Currently, we are witnessing peak in demand, approaching approximately 500 exajoule, as shown in the left figure. So fossil fuel consumption generates CO2 emissions, a major driver of climate change and global warming. So the anticipated peak in global energy-related CO2 emissions in 2025 is estimated at 37 billion tons per year, as shown in the right figure. So the power industry and transportation are the leading contributor to these emissions. So road transport currently contributes to 18% of global energy-related CO2 emissions, primarily from internal combustion engine (ICE) vehicles. So to meet the Paris Agreement target, we must reduce emissions by like 45% by 2030 and achieve net zero by 2050. So our solution is accelerating the transition from ICE vehicles to EVs. So the figure in the left shows a steady increase in EV sales, surpassing 10 million vehicles in 2022. And as EV adoption grows, so does the demand for electricity, surpassing 65,000 gigawatt hour in 2022. So as shown in the right figures. So to meet this demand, we must rapidly expand our EV charging station. So to efficiently power EV charging stations, we should prioritize renewable energy over fossil fuels. So solar PV have proven to be promising as they generate carbon-free electricity from solar energy, an infinitely renewable source, as we know. So the exponential growth of PV is reflected in forecasts as shown in the figure. So by 2027, installed capacity is expected to surpass that of coal and become the world's largest source of energy. So now with a clear understanding of our project rationale, we shall move forward to the introduction. So climate change is a severe global threat requiring shift from ICE vehicle to EVs powered by sustainable sources. So this transition, vital for the environment, strains the power grid. Enter PV charging station that offer a dual solution, reducing emissions, CO2 emissions, and grid pressure. So in this presentation, we will showcase the design of a PV-powered EV charging station, highlighting its exceptional organization and user-friendly control, offering a practical solution to address climate change. So let's now see the proposed system for our ongoing research. So in this setup, solar PV is the primary energy source for charging EVs at the station. To cover nighttime and peak demand, battery system supplements power. If there's an energy shortfall from solar or the battery, we tap into the AC grid of a continuous charging station operation. So to comprehend our system's operation, we must break it down, starting with the PV arrays. We've chosen the single diode model, essential in research for its incorporation of series and shunt resistors. Additionally, the interleaved back converter is our DC-DC converter of choice, reducing voltage levels, voltage ripple, and also enhancing efficiency. So furthermore, we have chosen the single inverter as our choice to convert AC power generated from the grid into DC. This inverter configuration integrates 4 IGBT switches. Also, the bidirectional converter serves as crucial components that enable us to adjust voltage levels either upwards or downwards as needed. So having detailed most of the components integrated into our proposed research system, I will now proceed to present the comprehensive overall system model in Simulink MATLAB. So illustrating how these components interacts and operates as a unified whole. So starting with the PV arrays, the DC load, the inverter, the grid, the interleaved back converter, the bidirectional converter, and finally both the batteries, stationary battery and the EV battery. So passing now to the results section. The results show the solar energy levels with sunlight peaking during the day and diminishing to 0 at night. So figure 1 and 2 show PV voltage and current values with MPPT regulating voltage around 500 volt for optimal PV efficiency. Figure 3 displays PV power starting at around 4,000 watts, while figure 4 shows a constant DC bus voltage at around 400 volts. So in the first case, when the electrical vehicle battery is connected, the stationary battery automatically disconnects and receives no power. So the current from the stationary battery is negligible as shown.
What happened? I cannot hear you. Hello?
Sir, you are not audible.
Could you hear me now?
Yes, now you're audible.
Okay, I will restart or just continue from this slide.
Sure.
Okay, I will continue from this slide. So the second key point is if the PV capacity drops to zero, so energy source from the grid and the DC load and the EV battery continue to operate. So in the second scenario, the stationary battery replaces the EV battery in the system. Figure top left shows the stationary battery current variation, while bottom left figure shows that the EV battery current is around zero. So in right figure, initially, the PV system generates 4 with the 1 kilowatt used by the DC load and 3 kilowatt by the stationary battery. When PV power drops to 2 kilowatts, 1 kilowatt goes to the DC load and 1 to the stationary battery. And finally, if the PV power reaches zero, the stationary battery supplies the DC load and the grid remains disconnected in this scenario. So if the EV is connected and there is a surplus PV energy available, the grid will establish connection with the system. Otherwise, it will remain disconnected. So the first figure shows the SOC of the stationary battery that fluctuates. We see at first charge mode, then discharge mode for the DC load when PV equals zero, then again charge mode. So the second figure shows inverter voltage, inverter current, and also grid current variation. So here's some key points to remember. So in this scenario, the stationary battery replaces the EV battery in the system. And if the PV capacity drops to zero, so the stationary battery takes over to power the DC load. So during this scenario, the grid remains, of course, disconnected. So in summary, our research has resulted in an optimal solar-powered EV charging station model, including solar panels, inverters, converters, energy storage, and also grid connection. So our iterative control system adjustments involving components like capacitors, inductors, or resistors have delivered promising and desired outcome as presented. So thank you for your kind attention.
Thank you so much.
Thank you.
What regularity or challenges in policy consideration arise when implementing innovative solar battery system?
Sorry, I didn't hear you. Could you repeat, please, the question?
What challenges and policy considerations arise when implementing this innovative solar battery system for electric vehicle charge?
Yeah, the first challenge is the irradiation. So in this paper, we propose like three change in irradiations. So when the power PV power like are around 4,000 watt, then 2,000 watt, then we suppose that it is zero. And based on that, we test the outcomes. The second challenge is the control systems. So in this paper, we utilize the different control techniques as PID or the MPPT techniques. So I think in this paper we used the simple and the conventional PO MPPT technique, the perturb and observe technique, and yeah, in this paper. But in ongoing papers we are like using different MPPT techniques and like observe the outcomes on them. So yeah.
Okay. And how can what maintenance requirements and reliability factors should be considered in the operation of solar power charging stations, and how can downtime be minimized?
The second question, please. How the
my question is what maintenance requirements and reliability factors should be considered in the operations of solar power charging stations, and how can downtime be minimized?
Yeah, of course. So the first thing that I could like think of is the PV, the photovoltaics maintenance. The second, it's the safety of the user that have like the EV charge in the stationary battery, and yeah, for the time to reduce the time of the charge, I think the most important thing is using like a good type of battery, the stationary battery, especially the lithium ion.
Okay, and how does the implementation of innovative solar battery system affects the economic feasibility and long-term cost benefit ratio of electric vehicle? When we talk about the cost benefit analysis, how does the implementation of this solar battery system affects the economic feasibility and long-term cost benefit ratio of electric vehicle?
So in this paper, we didn't delve into the economic or the cost feasibility of these projects, but yeah, in ongoing research paper now, we are delving into it, and as we know that the first investment, the cost is very high due to essentially due to the batteries.
So you can consider this cost benefit, And my last question is, how can the integration of solar powered charging stations can be effectively coordinated with an existing, electrical grid? And how can these strategies can be optimized load?
So we could like organize all the components via, I don't know, via some centralized system that we could create, or like a software to centralize all the data from the solar PV to the user data, and we could like explore all the data in some software. So
Okay, thank you so much.
thank you, ma'am. Thank you.
Thank you so much for your presentation.
Thank you.
This brings us to the end of our presentations. So, ma'am, I would like to have the session chairs to give valuable remarks for our participants.
Thank you so much, ma'am, for organizing such a wonderful conference. Thank you, Amit Joshi ji, for inviting me as a session chair. Thank you so much.
Okay. Yes. Thank you all for attending this session. I wish you all a happy time at this conference. Thank you.
Thank you so much, sir. Thank you, ma'am. So I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during the 9th version and all the previous 8th version of the conference. We're happy to have you in the 10th version as well in 2025. All our presenters would be getting the digital certificates through email within 2 working days. Further, all the papers have been forwarded to Springer. The publication would be live within 6 months. Kindly cooperate with the team of ICICT 2024. I would like to thank our session chairs for chairing the session. A token of appreciation to the chair on behalf of the team ICICT 2024 and Global Research Foundation and partners. Thank you. Thank you for your valuable presence.
Thank you, ma'am. Thank you. Have a nice day. Good night.
So I would like to have a final snapshot of the conference. So I would request everyone to please switch on your camera so that we can have the snapshot. Yeah. Thank you so much, everyone. Have a nice day. Take care. Bye-bye.
Thank you.
Okay.
Thank you. Thank you, ma'am.
Thank you. Goodbye.
Thank you. Thank you so
Goodbye.
much.
Goodbye.
Thank you. Goodbye. Thank you.
Bye-bye.